Hello, and welcome to the first episode of R&R, Research and Reporting. Today's episode, we are going to talk about climate change. But in order to talk about climate change, we have to define weather and climate.
Weather is defined as localized patterns of temperature, precipitation, and winds that change from day to day. And this is different from climate.
Climate is long-term weather. It's the usual temperature and general weather patterns. So climate is changing, but how is it changing?
We have been seeing record temperatures recently. And actually, if you are under the age of 30, you have never seen a below average year of temperatures.
Wow. And also the ice is melting, the sea levels are rising, and not just from the ice melting, but also as the temperature of the Earth as a whole warms up, water expands. And on top of that, we're also seeing ocean acidification. So what's causing these changes?
Well, there's more carbon dioxide in the air than ever before.
Actually, for 800,000 years, carbon dioxide level in the atmosphere has been between 180 and 280 parts per million. And now it's at 400 parts per million and continues to rise. Now, you may ask, how do we know carbon dioxide is the cause of the warming? We can tell because previous warming of the Earth has produced a rise in carbon dioxide after the rise in temperature. And recently, we are seeing a rise in carbon dioxide before the rise in temperature. It's human-produced carbon dioxide.
Well, how do we know that it's human-produced carbon dioxide?
We can tell by the isotopes in the carbon atoms. The plants prefer the lighter carbon, which would be carbon-12 rather than the carbon-13 that is normally in the atmosphere. So when we burn our fossil fuels, we see a larger amount of the carbon-12 in the atmosphere. Previously, the Earth has warmed and cooled in the past, but this was due to Milankovitch cycles, which is the change in the revolution of Earth around the Sun and the tilt in the Earth's axis rotates. And it is true that we only emit a tiny fraction of carbon dioxide compared to the rest of the Earth. We emit about 30 gigatons annually, while nature emits about 780 gigatons, and volcanoes only emit a tiny fraction at 0.25 gigatons. Previously, the Earth was in balance, absorbing and emitting the 780 gigatons per year. But that left our 30 gigatons per year left over in the atmosphere.
An overwhelming amount of scientists agree that climate change is real and that humans are the primary cause for climate change due to our CO2 emissions. 92% of human CO2 comes from coal, natural gas, oil, and gasoline, so all those fossil fuels.
And two of the biggest areas of carbon dioxide emission are generating electricity and transportation. 30% of our carbon dioxide emissions come from generating electricity, and 31% of our carbon dioxide emissions comes from transportation.
Recently, between 2012 and 2013, there was only one scientist to say the cause of the Earth warming was different. He said that it was the sun. In the 1950s, the sun was getting brighter, which may have caused some warming, but after that, it started to become dimmer.
We also know it's not the sun because the upper atmosphere isn't getting warmer like the lower atmosphere. If it was the sun, we would see all layers of the atmosphere experiencing some sort of change in temperature. Since we know it's not the sun, and it is the humans, what can we expect to happen?
Well, we can expect to see all the things that we see on a day-to-day basis in the year 2015, such as droughts, storms, wildfires, and ocean acidification.
The ocean has become 30% more acidic since we started producing CO2 during the Industrial Revolution. This causes harm to shell creatures and coral reefs, which then causes harm to food and shelter for other fish. At this rate, scientists predict potentially 1/3 of all ocean life will die off because they are unable to adapt to how acidic the ocean's becoming. 1 in 7 people get the majority of their protein from seafood. This could leave 1 billion more people to feed.
We will also see positive feedback loops. By positive feedback loops, I mean with more carbon dioxide in the atmosphere, it makes the Earth warmer, which we can have more water vapor in the atmosphere. Water vapor is a more potent greenhouse gas than carbon dioxide, which means that there will be even more warming from more water vapor in the atmosphere. With the water being warmer, it also absorbs less carbon dioxide, meaning there will be even more carbon dioxide in the atmosphere, making the Earth even more warmer, which means there will be even more ice melting, which means the sunlight will be absorbed into the ground rather than reflected off of the ice, making it even more warmer. It would just be cheaper and better for everyone and everything if we work to try and reduce the effects of climate change now.
In some countries, such as Australia, Germany, China, and others, are setting goals for implementing renewable energy. Germany has a plan that by 2050 to be almost entirely reliant on renewable energies. China is hoping to be 70% reliant on renewable energy by 2050. And last year, they put $83 billion toward renewable energy, while all of Europe put just $58 billion, and the U.S. just $36 billion.
China currently produces the most carbon dioxide than any other country per year. They produce 8.2 million tons. But if we talk about per capita, they're in the middle of the road with 6.2 tons per 1,000 people. The U.S. currently produces the second most of carbon dioxide per year with 5.4 million tons. And it's still in the top 10 when we talk about per capita. We produce 17.5 tons per 1,000 people. So it seems like the U.S. needs to do some catching up.
We currently have some existing technologies such as solar, wind power, and hybrid and electric cars.
One of those cars is the Honda Accord plug-in, which combines an electric car with a hybrid car, and it gets 115 miles per gallon. When we talk about solar and wind power, some of us think that it costs way more to build these power plants than others, but in reality, solar, wind, and coal all cost the same at $3 billion per gigawatt, and nuclear power is $15 billion per gigawatt. But with solar and wind, once they're up, there's no external cost. With coal, you have to pay to go out and get the coal to burn in your power plant. Some other problems with solar and wind power is the sun isn't always shining and the wind isn't always blowing. There are some new technologies in development, like the liquid metal battery, which is a low-cost, low-maintenance, and long-service lifetime that is able to store lots of energy for when the sun is shining and the wind is blowing. It can store that energy and then release it when the sun isn't shining and the wind isn't blowing. It works by using some abundant metals like magnesium and antimony. It has 3 layers. The top layer is magnesium, middle layer is a salt mixture, and then the bottom layer is antimony. And the way it's low maintenance is it keeps these liquid by the energy going through it, storing the energy, and then releasing the energy, and it keeps it heated up at a liquid state. However, it is currently too expensive to implement today. It's about $500 per kilowatt hour, and it needs to be about $100 a kilowatt hour. But they believe that within 3 to 5 years, we can see this on the market. Tesla Power has created a similar item, but for personal use. It's a battery that you attach to your house, and then if you have solar panels on your roof or a wind turbine, you can store that energy in that battery and then use it when the sun isn't shining and the wind isn't blowing. So this is what we can do as a nation, but what can we do personally?
Well, there's a lot you can do personally, but some of the easy things would be to swap out all of your light bulbs for more efficient light bulbs, When you're buying new appliances, look for the Energy Star. Heat and cool your house in a smart way, so that means seal and insulate your house. All these things you can do to help impact climate change in a positive way.
And you can also reduce, reuse, and recycle. Some easy ways are ask for paper bags that are easily recyclable, and reuse. If you have any plastic containers like butter containers, use those for Tupperware instead of throwing them out. And recycle. Recycle everything you can. Personally, I have 2 bins of recycling for every bag of trash. And especially recycle plastic. It takes forever to break down. Another way to save energy is to use water efficiently. You might not think that water uses energy, but the pumps to get that water to your house uses quite a bit of energy.
Some more things you can do involve your car. You can purchase a more fuel-efficient vehicle, but you can also just drive smarter, being easy on your brakes, slowly accelerating, and turning your car off when it's idling for more than 30 seconds. You can also check your tires and just have regular maintenance on your vehicle.
Very important is to vote for someone who believes in climate change and knows the importance of acting now for the future of the Earth.
And please, spread the word.